So trigonometry is the study of triangles. We can see here a picture of the Taj Mahal and how triangles were used to design it so that it structurally works and also aesthetically. Although trigonometry talks about lots of different types of triangles, we're specifically at junior cert higher level. We're only going to look at the study of right angle triangles. If this is leaving cert ordinary level, we're going to look at right angle triangles and move on to different types of triangles. So whether you're junior cert higher level, leaving certificate ordinary level, or leaving certificate higher level and just want to do a little bit of revision, this lesson is for you. So right in front of me here, I have a right angle triangle. Now we've been looking at right angle triangles for many years at this stage, and we know a certain amount about them. We know that obviously in a right angle triangle, this amounts to 90 degrees, and it means that these two lines here are perpendicular. We also know that in a right angle triangle, we have a very famous theorem that works, which is of course Pythagoras' theorem. Now we have different ways of remembering Pythagoras' theorem. One of the ways is c squared equals a squared plus b squared, where c squared is the longest side. And that is always opposite the right angle. So we're not going to forget about Pythagoras. Pythagoras is still important, but we're going to look and learn a little bit more about right angle triangles. So although in Pythagoras we refer to these as C, A and B, they actually have proper mathematical names, trigonomic names. And so we're going to look at what are these sides of a triangle actually called. So the first one we're going to learn is always right opposite the right angle is the longest side, and we call that the hypotenuse. Now there are two other words for the other two sides of a triangle, and they are opposite and adjacent. Now where these goes depends on another piece of information that we're given. It depends on where is the marked angle. So if I was to mark an angle within this right angle triangle, there's different ways we can mark it. Sometimes we could call it, say if I was to talk about this angle here, I could call that angle there angle A. Okay, I could call it angle B, I could call it angle C, but a lot of the time in mathematics is we use this symbol here, which is called theta. So it just means the angle, it's just a Greek letter. So if this is my angle, and we'll keep it A in this case, okay, or we'll keep it theta, actually, we call it theta. If this is where the angle is given, remember this is given to me, I don't fill this in, it's given to me in the question, then right opposite where the angle is called the opposite side, okay? And then that means that this last one here, the adjacent, goes here. So labelling a right angle triangle is so important. If we don't do this right, we can't do any of the rest of the stuff. So I'm going to take these three things away again, these three words, and I'm going to change the angle, and I'm going to say that this is my given angle this time. So it's up here, okay? And I want to label everything. So in all of your right angle triangles, you're going to have these three words: hypotenuse, opposite, adjacent. So the hypotenuse is probably the easiest one to start off with. Remember, it's always opposite the right angle. So I'm happy enough with that. Now, the next one is I look for the given angle. So in this triangle now, this is the new triangle, this is the given angle, which means if I was to draw away opposite from that, it would be down here. And so this is opposite. And this would be then, the last one would be the adjacent. So depending on where your angle is, it will sort out whether it's adjacent or opposite. Okay, so again here, I'm going to label the following triangle. Okay, so here is my right angle triangle. Here's my right angle, and we refer to this as the given angle. So let's put these labels where they belong. So the first one is, I'm always going to do the hypotenuse first. So I find my right angle, and my hypotenuse is the longest side. So I'm going to move that one up here. Then next thing is I look to my given angle. So here's my given angle, and opposite the given angle would be this side here. So that becomes opposite. And I'm left with adjacent. Okay, over on this triangle here, I'm going to put in the hypotenuse. So I'm going to remember the hypotenuse is always right opposite the right angle. So that's fine. Adjacent, I do last. Opposite is the one I do next. So I'm looking to see where the angle is. Here's the angle. So right down here would be where the opposite is. So you're just drawing a line opposite it, and then adjacent is here. So being able to label the triangles properly is super important. Okay, so I have given you 5 right angle triangles. I've given you a given angle in each of the right angle triangles, and I want you now to see if you can label all of these. So press pause on the video because the next slide will be the answers. I want you to go through these, see if you can label them, and then hopefully you'll be getting the right answer. Okay, so this is my hypotenuse, this is my opposite, this is my adjacent in the first one. My hypotenuse, my opposite, my adjacent in the second one. My hypotenuse, remember just opposite the right angle. My opposite, my adjacent. So you can put little brackets around them either. And then I've got hypotenuse, opposite, adjacent, and then hypotenuse, opposite, adjacent. So you can see depending on where the angle is, that really changes things. So try again with example 2. So here we have example 2. I've called them A's and B's. Can you label those triangles for me? Press pause now because the next slide I'll be correcting. Okay, so I've got hypotenuse, opposite, adjacent, hypotenuse, opposite, adjacent, hypotenuse, opposite, adjacent. Go down to here, so I've got this my hypotenuse, this my opposite, this my adjacent, and then hypotenuse, opposite, adjacent. Okay, so it doesn't matter if you put brackets around them or not brackets around them, but hopefully you've gotten the hang of that now. So you may be asking yourself, why are we learning this? Okay, if I was to give you, say that this, the length from here to here is 5, the length from here to here is 7, and the length from here to here is x. And I said, would you be able to find that? Hopefully you'd spot it's a right angle triangle and you would do Pythagoras' theorem. But what happens if we're given, say, 2 sides and we're given, let's imagine we're given all 3 sides. So let's say that that one was 4, and I'm asking you to find the angle. What is that angle? So we use trigonometry when we're trying to find angles, or if we're given angles and we're trying to find sides. So that's what the aim is. The aim is if I give you a triangle like this and I say, what's the angle? You're going to be able to find out. The most important thing to remember is we can only do this with right angle triangles, okay? So just be conscious of that. So if I asked you to find an angle, we're going to have to use these very famous trigonometric ratios, which are sine, cosine, and tan. Okay, now we're going to have to remember the order that they go in, but it's not actually too bad. I actually have a nice little rhyme that I use, and it is, oh hell, another hour of algebra. And what does that mean? That means for sine, it's going to be opposite over hypotenuse. For cos, it's going to be adjacent over hypotenuse. And for tan, it's going to be opposite over adjacent. So I'll write those out in a nice way for us now. Okay, so we say the sine of theta, and remember that theta means the angle. So actually in this case here, we've called the angle A. So I might change that to A. So the sine of A is equal to, so it goes O hell, so O over H. The cos of A is equal to AH, another hour. And the tan of A is equal to OA. Now, hopefully you know what these words mean. The O stands for opposite, the H stands for hypotenuse. Cos of A stands for adjacent, H stands for hypotenuse, and so on. So you need to be able to write these out. Okay, remember this bit here will be whatever we call the letter or whatever we call the given angle. But these are not in your log tables, and you need to be able to write these out on the top of your page when you come to your trigonometric question, because you're going to need all of these to solve it. Okay, this is the learning check, and what I'm going to do is I'm going to create a quiz online so you can just fill in the answers to this. But I'm going to do the first one with you today. So it says, use the theorem of Pythagoras to find the hypotenuse of the triangle. So hypotenuse is the longest side, so that one there. And then when we've done that, write down the ratios. So I probably haven't used that word enough, but when we find sine, cosine and tan, we're actually finding trigonomic ratios is what it's called. So we'll start off by using Pythagoras' theorem to find the hypotenuse. So remember, that's my right angle there. So therefore this is my hypotenuse, which is my longest side. So it's c squared equals a squared plus b squared, or you might have learned them in a different order, that's 100%. So it will be, we don't know what this is, so I'm going to call it x. So it will be x squared equals 5 squared plus 12 squared. X squared equals 25 plus 144. X squared equals 169, square root both sides. And I'm getting x equals plus or minus 13. But remember, obviously we're dealing in distance here, so it can't be a negative, okay? But just to be conscious that it can be both answers in algebra. But obviously when we're dealing with distance, it can only be plus 13. So I'm now going to fill that information in. Oh, I think I want to just undo that. No, just get rid of the bits I've drawn. Okay, and the first thing I'm asked to do is find, so part A here, it says find the sine of B. So the angle B is the one we're looking at here. So what I'm going to do first of all is I'm going to write up my information up here, because that is super important and it's not given to me anywhere in the log tables. So it's the sine of B, the cos of B, the tan of B. And I'm going to write, oh hell, another hour of algebra. Okay, so the sine of B, so let's label everything. So this is still going to be my H, and if B is my given angle, then this is going to be my opposite, and then the last one here is going to be my adjacent. So sine is opposite over hypotenuse, so the sine of B is going to be opposite, which is 5, over hypotenuse in this triangle, which is 13. So that's the answer to the first one there. I want you to do cos of B, tan of B, so do the answers. And then we're going to sine of theta. So remember, when the angle changes, we've got to relabel the triangle. And then we're going to go through these and fill in as normal. So there's a quiz up now, just getting you to put your answers in for these next. And that's lesson 1 of trigonometry, just labeling triangles.